Okay, section 5.6, numbers 8 and 11 on this one. So number 8 says we're heating a plate on a circular plate of metal. We'll just draw a little picture so we can see it. It's heated in an oven. Its radius increases at a rate of 0.01 centimeters per second. So that's dRdt. That's the rate of change in the radius. I always write these numbers down when I'm doing it too. It's 0.01 centimeters per second. Sometimes we have to be careful about units. Sometimes they switch them on us in the middle of a problem, so just be careful. At what rate is the plate's area increasing? So that's the rate of area, so that's dAdt, when the radius is 50 centimeters. So first we need a formula that relates the area and the radius, which is just our pi r squared. Now we're ready to take our derivatives and introduce our rates. So we're going to go dAdt equals 2 pi r, that's or that, but then the chain rule, implicit differentiations because it's a function of time, dRdt. We're trying to find dAdt when r is 50, and we know that dRdt is 0.01. So I could probably do this without a calculator, but I'll go ahead and just use the calculator. You can leave your answers in pi. You can leave them in decimal form. It doesn't really matter. So we're going to go 2 times 50 times 0.01, I guess, which is just 1. Hey, look at that, which is just pi. And then we have units. In this case, we're centimeters per second, but now it's area, so it's going to be centimeters squared per second. I always like to check my answers. Hopefully you're doing the same thing. This is problem number 8. And we're going to grab that answer there, and it's pi centimeters squared per second. Good. So now we're going to move on to problem number 11. Problem 11, a spherical balloon is inflated with helium at a rate of 100 pi cubic feet per minute. So that's volume. So the volume, we're putting air into this balloon, so we're changing the volume at 100 pi cubic feet per minute. And then it says how fast, so part A is how fast is the radius increasing. So that's fine, the radius increasing, which is dRdt, when the radius is 5. And then we'll bump down here for part B, which is how fast is the surface area increasing. So we'll go d surface area, could just call it an S, at the same time. So first we'll need our little volume formula. Volume formula is for a sphere 4/3 pi r cubed. So we'll introduce the rates. dV dt equals, we'll drop that 3, it's a power rule, so we're going to get 4 pi r squared dRdt. The question is find dRdt when r is 5, but we also know the volume is 100 pi. So this is 100 pi equals 4 pi, my r is 5, so this is 25 dRdt. We're going to come up here, and we're going to go dRdt equals 100 pi divided by 25, 100 pi. Look at that. We're going to check that answer again. Always a little weird. But we got 1, and we're in units. This is the radius changing, so 1 foot per minute because it's linear. Let's just check my answer on number 11 there. Yeah, we're all good. And then part B, surface area. So the formula for surface area is 4 pi r squared. Not a formula that most people really remember or memorize, but it's 4 pi r squared. So again, we introduce those rates. d surface area dt is what I'm trying to find. 8 pi r dRdt. 8 pi, my r is 5. And now I can use that dRdt from the last problem, which is 1. So it looks like 40 pi. Now we're surface area, so that's squared, right? 40 pi feet squared per minute for number 11. We're looking good on that one. I'll be back on the next video for 13 and 14.